Hey y'all, welcome back. Today in this video, the purpose is going to be just to get some more examples from graphing rational functions. We looked at some really basic examples in the first video. They do get a little more interesting even than that, and so we're going to start to see today how to deal with those situations. So what it's going to be is we're going to have just 5 examples that we're going to run through. Pause the video when you need to take notes, pause the video when you want to try the questions on your own, and I hope you enjoy it. So let's get to it. Okay, let's look at this first one. Okay, in the first one, what jumps out at me right away is a couple things. I can glance at this and I can read off the horizontal asymptote. How can I do that? Okay, I'm looking, remember, right here at the beginning. That's something divided by itself, so that's 1. And I can go ahead and put that in right now, and I think I will. Okay, what else can I get just by looking right here? It looks like I can also get the Y-intercept. And for that, all I'm doing, I'm looking at the constant terms. Looks like negative 15 divided by 3 is negative 5. So I'm going to come down here to negative 5, and I'll put my point. What's not as obvious is the vertical asymptote, or asymptotes, and the zeros. Okay, and so what I'm going to do, what I see that I probably can do, is it looks like this is factorable. So let's see. So x, and I'm hoping the denominator is factorable too. We'll see here in just a sec. So let's talk about numbers that multiply to be negative 15 and add to be 2. Looks like minus 5 and positive 3. And then what about down here? That multiply to be 3 and add to be 4. Looks like plus 3 and plus 1. And so luckily, those cancel out. And maybe now we can answer these questions. What are the zeros? Well, there's 1 at 5 because that's what makes that 0. So we'll come out here to 5. What about my my asymptote, my vertical asymptote that comes from the denominator? It looks like that's at negative 1. And so it looks like maybe this one's no more complex than the first video. Just kind of a warm-up for us. Okay, be close to the asymptote, hit the points, and that's a little bit more herky-jerky than I'd like, but that's how it goes. And then if we plug in a big negative number in here, it turns out that it's up here. So we'll just get in that part of the sketch right now. Let's go to example number 2. Once again, I want to try to factor this. So the numerator factors as x plus 2 times x minus 2. That's a difference of squares. What about the denominator? Looks like that one might be a little more challenging. Let's see. Numbers that multiply to be 6 and add to be 5. How about 2 and 3? So x plus 2, x plus 3. All right, so this one's no more difficult either. It's just more of the same thing. Okay, so let's now find all those pieces of information we need. So how about the y-intercept? That's at negative 2/3. How about the zeros? That's at 2. Let's plot it. How about the horizontal asymptote? Well, that's an easy one. That's 1. So dot, 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 dot. What about the vertical asymptote? That's at negative 3. All right, let's do a little bit of sketching. So close to the asymptote, hit the points. Close but never hitting that asymptote. Same thing over here. All right, 2 down. Let's see what the next 3 have in store for us. All right, let's talk about the y-intercept first. Remember, that's what it is, or that's the value, the y value, when we plug in a 0 for x. That'd be 0 squared over 0 squared plus 1. That's 0 over 1, so that's 0. Now, it doesn't look like I can factor this, so let's just keep going. Let's find the 0. What would make the numerator 0? That would also be 0. We've already graphed that. What about the horizontal asymptote? Okay, that comes from x squared over x squared. And that's something divided by itself, so that's 1. And then what about the vertical asymptote? That would be whatever value makes x squared plus 1 equal to 0. Let's see what happens. So I get x squared equals negative 1, and I take the square root of both sides. Interesting. This is a case where there is no real vertical asymptote. Okay, because we can't have a square root of a negative. So we're actually sort of stuck here. Now this gets kind of interesting. That looks a little bit challenging to graph because we're so accustomed to having multiple asymptotes to work with. What I think I'll do here is I might pick a couple values of x just so we can illustrate what happens. Like, let's say that x equals 1. Then what do we get? 1 squared over 1 squared plus 1. So that would be 1 over 2, 1/2. Let's try a different one. Oh, and by the way, if x is -1, it's the exact same thing. How do I know that so quickly? Because whatever you're plugging in is getting squared. It'll be made positive. So this actually has symmetry. I can already see that. It has y-axis symmetry specifically. Okay, what about, let's try another one. How about x equals 4? So if x equals 4, then what we have is 4 squared over 4 squared plus 1, or 16 over 17. That's really, really close to 1. Now that shouldn't be too surprising. All that's saying is we're getting really close to our asymptote. So that tells me that I've got something like this, closer and closer and closer, and something like this coming out this way, closer and closer and closer. And there's my graph. Kind of looks like some bird wings or something like that. Okay, so this is our first example where it's really been necessary for us to plot some solution points. Solution points, all that means we're picking x values, figuring out what y values accompany them for this function. Okay, so don't be afraid to do that if you get stuck on a homework question or something like that. All right, what about this one? First thing that jumps out at me is it looks like I probably can factor it. Let's see, numerator won't factor, but denominator should. Numbers that multiply together to be -2 and add together to be -1. Looks like that's probably x minus 2 and x plus 1. And that looks like parentheses, but that's a 1, a big old uno. Okay, so now let's try to write down the information that we know. So what about our y-intercept? The y-intercept is when x is 0. So that would say 0 over something, that would be 0. What about our 0 or our x-intercept or x-intercepts? That's what makes the numerator 0, so that would be 0. Looks like those are both the same point. What about our horizontal asymptote? Let's see. We go back to the original equation. We're going to use x over x squared, and that would simplify down to 1 over x. And we have to remember, the horizontal asymptote is what happens for big x values. So 1 divided by a big number so big it's like infinity, 1 divided by infinity, functionally, that's 0. So the x-axis is an intercept, or is an asymptote, excuse me, rather here. And let's do the vertical. For the vertical, I'm looking at the denominator. It looks like we have 2 of them this time. 2 and -1. All right, this is our first time when we've had 2 of them. This will be kind of interesting. So let's plot those in now. Oops, meant to make that dotted. Didn't quite work out. Okay, and -1 over here. All right, so we have our asymptotes on there and our zeros. Okay, so this is where it gets a little bit fun. What I'm going to do is I'm actually going to plot a few points to try to help us graph this a little better. So what I'm noticing right now, we already have x equals 0. I don't have anything for x equals 1, so let's do that. If x equals 1, let's see what we have. We have 1 over 1 minus 2, that's -1, and 1 plus 1, that's 2. So I get 1 over -2, or -1/2, which tells me that this point's right here. Now y'all, here's all I have to know. Because right now, I know it's going to cross through at that point. So what I'm going to do is I'm going to come down to this point, I'm going to hit it, and then it's headed toward the asymptote. The asymptote's just kind of going to funnel it in this way, and it's going to come down like that. Okay, what about this way? This one is just going to come up on this side toward the asymptote, and the asymptote's going to kind of funnel it vertically as well. Now let's deal with what happens out here and out here. Let's work on the right first. I'm going to pick a value like x equals 3, so it's clearly over to the right. Let's plug in 3 and see what happens. 3 into the numerator is 3. 3 in the denominator, 3 minus 2 is 1. So that would be 1 times, and looks like 3 plus 1 is 4. So that would be 3/4. That's all I need actually, because that tells me that that point is on my graph. Remembering that my horizontal asymptote was the x-axis, I'm going to come through like this, and the asymptote's going to funnel it up, so I have this part and that part. And then I'm going to come over here to the left, and I'm going to pick the easiest x value I can think of over here. That looks like that would probably be -2. X equals -2. So what do I get then? I get -2 over, let's see, -2 minus 2 is -4. And then I get -2 here. -2 plus 1 is -1. So what do I get? I get -2 divided by 4. -1/2. All right, there's my point. And that's all I need to know over here, y'all, because I'm close to the asymptote. I take a break to hit the point, and then I'm back to the other asymptote, and I'm just going to funnel that along. All right, So pay attention to the principles here, okay? Because this is going to make not any question, but most questions pretty doable. We stuck with our guns in the beginning. We found all of our asymptotes. We found our zeros. And then we plotted solution points sufficient to where we were able to graph it. For me, that meant I needed 3 additional points in order to feel comfortable graphing this. You may need more. That's possible. It's really unlikely you could get away with. Example 5 is very similar to example 4, so you guessed it, this would be a good one for you to try on your own. I'm going to start by factoring, because that just looks like something that might work on this one. I hope you've noticed that theme. It's pretty common that we can factor them. Okay, so let's see. We're looking for numbers that multiply to be -6 and add to be 1. Seems like that would be x plus 3 and x minus 2. Right off the bat, I'm going to look for my y-intercept, and that looks to be -5/6. So let's graph that. Look for my zeros. What would make 5 0? Nothing. Okay, frowny face. There aren't any real zeros on this one. And let's keep going. My horizontal asymptote, that's going to come from 5 over x squared. Remember, we're looking at for really big numbers of x. 5 divided by a huge number, like 5 pizzas divided by all the people in the world. The people in the world don't really get pizza. Sorry, people, you're going to be hungry. That's 0. Okay, shortcut for that, by the way, is if you notice the power on bottom is bigger than the power on top, automatically the horizontal asymptote will always be 0. Okay, that's always going to work out. What about the vertical asymptote? Now with the factored form, we can glance and see that we're going to have 2 of them, -3 and +2. So let's sketch those in. Getting a little sketchy. And +2. Okay, and then the rest of our time in this example is pretty much going to be spent getting solution points and testing them. So I'm going to try x equals 1. Let's see what we get. We get 5 over, and I'm plugging ones in here, mental math here, y'all. So 1 plus 3 is 4, and 1 minus 2 is -1. So I get -5/4. So -5/4 is like 1.25. Okay, that's not real surprising. I can do this part now and go down to the asymptote. Just for fun, I'm going to try a number just to the left and make sure it doesn't curve back downward, because I suspect that it does. And here's why. Right here, it can't go up like that because we've identified there are no zeros. And in order for it to cross the x-axis, it would have to have a 0. So I'm just going to demonstrate that that won't work by picking a negative value for x, like -1. And let's see what happens when we plug that in. So plug in a 5, and I get -1 plus 3, that's 2. And plug in a -1 right here, and I get -3. And so when I do that, I get -5/6. So -5/6 is actually up a little bit. Interesting. It's less than 1. Just to feel safe, let's try another solution point. Let's try -2 and see what happens. So 5, what we get is 5 over, plugging in a -2, 1, and -4. And so I get -5/4, the same as when we plugged in 1. And so that then demonstrates that this thing has started to hook back downward again. All right, and so as we expected, it did not cross over the axis there. Couple more x values and we'll be all done. I'm going to try 3 because it's my smallest value out to the right of this vertical asymptote. So let's try 3, and then I get 5 over 3 plus 3 is 6, and 3 minus 2 is 1. So I get 5/6, which is right in there somewhere. Stay close to the asymptote, hit the point, now to the other asymptote. Okay, and so that one's all done. And let's pick one out to the left here. How about -4? And what do we get? We get 5 over, looks like -1. And then a -4 in here makes a -6. So on this one, I get, multiplied, sorry about that. And so I get 5/6 for this one, okay? And the only thing that matters there is that it's positive. And notice, same value we got here. So this has some symmetry to it. Okay, so close to the asymptote, take a break, hit the point, now to the other asymptote, and we are done. So in this one, we were able to factor, just like we normally do, we were able to find these 4 key factors, both types of asymptotes and both types of intercepts, and then we needed to 1, 2, 3, 4, 5. We had to find 5 solution points on this one, actually. Okay, now again, if you're not comfortable with 5, do more. You're just going to keep plotting points until you feel comfortable. Once you get the hang of it, it doesn't take that long to do. It's not super hard. Really, where the challenge lies in this is recognizing that we have to find all these things, and you do just have to remember that in order to find the horizontal asymptotes, that's blowout method. Vertical asymptote, that's looking at the denominator for zeros. and the zeros come from the numerator. All right, y'all, that's our 5 examples. Hope you enjoyed it. We'll see you next time.